minimizing charisma, maximizing intelligence, shooting someone in the crotch with a cannonball, thrust, propulsion. It's science-y.
Why you always gotta be blowing my spot up like that? There are my runes. There they are. I'm not mad. Science needs art and art needs science. They both need each other to function properly.
There are ways to figure out what the paper is really saying.
And then I'm ready to get on Twitter and yell at people about doing their own research on...
Oh, hold on there, sports fan.
Kyle Hill, everybody, is the next generation of science communicator. I'm going to be too old at a certain point to do those terrible things to my body, and it'll be up to you.
He's got like a lion's mane. This guy's amazing. Kyle Hill.
I'm Boo Rambo.
The universe is indifferent to you. Whether or not you have amazing hair, the universe doesn't care.
How are trees pushing past this pressure limit? Behold, my balls. Now we're getting somewhere, but I still don't think it's worthy of G.R.R. Martin's suspender.
I'm totally right? Post up photos of my frickin' hair? Is that what you all want? No, you don't, weirdos.
Kyle Hill. Is your last name actually Hemsworth? What's going on?
Our resident Thor lookalike?
I prefer Black Friday Chris Hemsworth.
Oh, thank you.
Hey, you know, if you need a haircut... No, of course not! We're not gonna send sharks with frickin' laser beams on their heads to an asteroid. We're gonna nuke it. You don't need Bruce Willis at all. Wrenched. Oh! Headshot! Oh! Kevin, turn on the monitor. Kevin, this transition better work. The blast doors can't... Kevin, turn it on. Kevin, call his agent and have them call my agent.
Kyle Hill, happy birthday! Feliz Navidad!
I'm just a biologist. I don't know how this works. This is how you do science. Can I just grab it? Oh. Laws, corollaries. Bye-bye.
I know that global catastrophe isn't the most fun thing to think about all day unless you're me, so...
Are we gonna do some science, bro?
Lasers don't have that much momentum.
That's not how clockwise works.
Don't worry, you can do this even if you are not an AI.
Completes the boundary layer around a person through a dynamic. And I guess it matters what kind of dragon we're talking. To realize here is that the bigger the thing does.
If this kite is completely inaccurate, I'm gonna kill this guy and tell him to his face. You're wrong about physics. Not enough lift force. Oh.
Nuclear metal donut thing with magnetically confined star-like plasma. The radiation flux in here alone is enough to cause instant death.
That's really funny. I like that idea.
Hey, look at me. I'm a streamer. I have a bedroom. We know anything with a decapitation hazard deserves to, yeah.
Ooh. Oh, that's good. That's fine.
Put it on PBS. I dare you. Yeah, no, I feel okay. It's just that, you know, I've been out here for a long time. Yeah. No, I've been up here for like, what, 5.5 weeks without going live? Yeah, what are you talking? No, I still got it. No, like, I can still be live. Like, I'll... Yeah, no, I mean, I was sick, and then I was worried that I wouldn't be able to do my job thinking thoughts anymore, and so that's why I kind of sound weird. Yeah, no, it passed right by me in the ship. I mean, you should have seen this thing. It was going 14,800 miles per... What? Oh, no one says it like that? Yeah, it was going 14,800 miles per hour. No, I'm not... No, I'm not slipping. I know how to speak live in an intelligent... What's that? What do you mean you're my wife? Who put you up to this? Oh yeah, if you're my wife, what's the name of our cat? Lady 3 Jane Tessier Ashpool. Damn, you're good. Okay. See you in... What? Mm-hmm. Yeah, I'll get some green onions. Love you. Oh. Hey. It's been a long time. Let's get back into it in this episode of Office Hours. Whoa. Man, that landing gets harder and harder every single time. Chat, welcome back. The triumphant return of Office Hours. Hello, I'm Kyle. For the next hour or so, we are going to go through all of the best in science, technology, engineering, arts, and math from the last, well, over a month since I've been out. Today we'll be going over the DART mission, NASA's attempt to redirect an asteroid. I'm going to tell you, hopefully, everything that you need to know while answering your comments, questions, corrections, comments about my hair and face. If you want to join the facility for what we do here, especially when I'm not live, you can go to patreon.com/Kyle Hill to join the facility today. If you want to continue on this conversation, of course, you can try super chats in the chat, or you can just comment. Like Jacob Cowart did with the 10, says, security is so loose around here, all I gotta say is I'm Kevin, and I can enter anywhere I want. You just let this guy in? His name's Jacob. Can't promise I'll get to all of your super chats, but even if I don't get to yours, please know that it is all going towards what we do here at the facility: science, education, exploring and explaining everything underneath the stars and beyond, and fixing this light. Oh, I guess it's fixed. That's great. And fixing that light. And for the next hour or so, I'm going to be your guide through this amazing NASA mission. Thank you, Jabo and Heather, for being here, for modding. Be nice in the chat. What we're going to get up to is some fun. And right after this, that's what I was stalling for time. Right after this, you will be automatically redirected. You can always click out. But right after this stream is over, if you want to see Scientist Plays, that's me, playing video games while sciencing some of the best video games of all time that need sciencing, we'll be playing Titanfall 2 over on the gaming channel. So look forward to that. I've played through it before. It's fantastic. Your boy says your room looks great. It's not a room. Do rooms have DNA lava lamps? No. I want to see Alien, says Eddie Huerta. Well, you might have to wait a little bit longer. So as we go through today, is Kyle going gray? Yeah, I'm going a little bit gray on the sides here. Yeah. As I said at the top, if I seem off, it's because this is the first time I've been live in 5.5 weeks. Still, getting my bearings, getting back into it. I was sick. Which seems to have modulated my voice somewhat, and hopefully my brain is still all there. Coming up, we have a bunch of cool stuff coming up at the facility. We can get to that later on. I hope you've been enjoying things that we've been doing here since we were last live, including, everything from Lord of the Rings Eagles to going inside Chernobyl and looking at the sarcophagus. Wait, how old is Kyle if he's going gray on the sides? First of all, so let's get right into it. Many of you I know in chat were saying that Kyle is timeless. He's 742 years old. When 742 years old you are, look so good you will not, I think. I'm already losing my mind. Didn't take that long. So many of you in chat were saying you caught the DART live stream. DART, of course, stands for the Double Asteroid Redirection Test. I watched it. Put a hands up in the chat if you actually watched this for real. It was pretty cool. The live stream was showing one frame or one picture per second from this robot or probe approaching this asteroid. So the next however many minutes is going to take, we are going to go from start to finish of this mission, what it means, why they did it, why it's important, and we'll be using, if you're just listening, I know some of you just listen, but we'll be showing some very cool footage as well. And some footage of stuff you may not have even thought about. Why do a test like this? Well, natural disasters, by and large, acts of God, as legal documents would call them, are unavoidable. But there is one natural disaster that is preventable. And that natural disaster might also be the most dangerous one of all. Of course, I'm talking about a large asteroid. Now, asteroids that are smaller than a meter or so, or it might be a little bit larger than that, 10 meters, what is it, 25 meters, maybe? Any asteroid smaller than 25 meters across, which isn't that, 100 feet, 75 feet, will burn up in the Earth's atmosphere. Going at orbital velocity, not orbital velocity, but going at the velocities that these objects move in space, it's going many, many, many kilometers per second. It's going like Mach 20 or Mach 30 or something crazy like that. So most asteroids that are smaller than 25 meters hit the Earth's atmosphere, compress it, that rapid compressive heating heats up the surface of the asteroid, the surface turns into plasma, it becomes unstable, it breaks apart. If you want to test out compression heating for yourself, if you have a bike pump, just pump the bike pump a couple of times and then feel the pump. It gets warm. You can actually do that little experiment in your own home. That is the same thing that happens when an asteroid comes screaming into the Earth's atmosphere and a lot of air gets in its way. Sammy B with the 10. Thank you. Now, asteroids larger than 25 meters do not get destroyed quickly enough. They're moving fast enough that they still generate this heat, this plasma, etc., etc., but they are so large that they do not break up, or they do not heat up in time to destroy it. Remember, if we're talking about many kilometers per second, let's say 10 kilometers per second, then to get from the edge of space to the ground is 10 seconds. As we all know, space is about 100 kilometers above your head right now. So if something's going 10 kilometers per second, and I think these are going much faster than that, that's 10 seconds. If it's going 20, that's 5 seconds. So just 5 seconds of heating, that's not going to stop something that's like a kilometer long. That's what we're really worried about. Those are the city killers, the country killers, the earth killers. And they are out there. And we have cataloged most of them in our near vicinity. So why do a test like this? Well, like we said, this is the only natural disaster that could wipe out all life on Earth and could be prevented. There are a number of different ways that scientists and engineers have proposed over the years to prevent such a calamity. From nuking it, which could be a possibility for some, gravitational tugboats, laser bees, but this one is probably the simplest, which is called a kinetic impactor, which is just a fancy way of saying smash it. Hit it with something. How do we see the asteroids between us and the sun? Says Alex. Alex, we look at the sky with telescopes. So can we impact it in time to do something about it? Well, that's why we keep our eyes to the skies for these near-Earth objects and beyond, the ones that are larger than a kilometer or of a certain city killer size, like 100 meters. We look at the skies at all times to catalog these things to see if they are on a path that might intersect with Earth. And the more that we do that, the sooner we can catch them, which gives us more time if we had to redirect them. How could such a little satellite impact to an asteroid change its trajectory, says the Watcher? Perfect segue into what we're doing. So this is the simplest. This is a kinetic impactor. This little robot doesn't have any fancy electronics on it. It basically had a navigation system and a camera, and the rest of it is just mass to hit this thing. Now, when I say this thing, what am I talking about? I'm talking about, at scale here, so what we're saying, DART is a spacecraft, 19 meters long, because of its large solar panels and radiators. Dimorphos, which is the asteroid that we hit yesterday, 163 meters across, large enough to be dangerous, as we just pointed out with our 25-meter threshold. Now, Didymos almost a kilometer wide. Didymos is the parent asteroid to Dimorphos. So Dimorphos is orbiting around Didymos in a binary asteroid system. Everything in space gets more complicated than you think. Now, we chose this asteroid again. It has no trajectory towards Earth. It's of a good enough size that we can test it, and we can point a lot of telescopes at it. Sammy B with another 5. Thank you, Sammy. So here's a little bit of Didymos and Dimorphos. So you can see this is not to scale. This is showing the relative positioning of Didymos and the Earth around the Sun. Now, we chose this timing because this is when Didymos, which I will just call Diddy from now on, and because asteroids can be rather porous, I might just call it P. Diddy. We'll see. But because Diddy was at its we chose Diddy at its closest point to Earth, such that we'd have the best opportunity to observe what happened from the ground. Now, even see that little, see when they're, oh, damn. See when they're right next to each other? Now that looks like it's pretty close. Kyle, that seems too close to be dangerous. Again, I said not to scale. Right there, P. Diddy is still 4 million miles away. And for context, the moon is 300,000 kilometers away. Or 384,400 kilometers away. So that is still very far from us. It's not going to hit us. Okay? So the idea was to, or is to, this was successful, was to send this kinetic impactor and hit Dimorphos around P. Diddy. Now, you can see the orbit is coming counterclockwise in this description, in this image, and DART is hitting it head on. DART is hitting it head on in such a way to slow it down. Now, you may or may not know that to conserve momentum in an orbit like this, if Dimorphos slows down, Sammy B, thank you, my man. Sammy B, keep going, ignore me. What are you talking about? I've read every single one. You're not putting a comment on your... Sammy, calm down. Listen to me talk about P. Diddy. So, to conserve momentum in this orbit, DART hits Dimorphos, and to conserve momentum, as I keep saying and forgetting what I'm going to say next, it slows down. And slowing down to conserve momentum, the new orbit around P. Diddy gets smaller. And in getting smaller, it orbits more often. Okay? That will be important later. Now, getting all this sorted out, oh, other people are having the same problem? Anyway, so getting to P. Diddy and Dimo was no simple feat. T-Car with the 1999, it says, Thor, you are okay for a god. Still worthy, baby. We're talking about speeds in the kilometers per second, millions of kilometers away, hundreds of millions of kilometers away. And you see the sun at the center there, and you'll see DART and everything else intersect. This is not an easy job. And what always amazes me about how well we know orbital mechanics and physics is that we can plan this out years in advance and know next year or next 5 years, this celestial object will be at this exact place and time And if we can launch a rocket going many, many, many kilometers per second and hit it exactly. Look at all these moving objects. We have equations and computers and scientific principles that let us be this specific, hundreds of millions of kilometers away. I think that's incredible. But okay, so why do we do a test just like this, right? If we have all that science figured out, as I was just saying, shouldn't you be able to do a simple calculation, right? DART weighs 600 kilograms. Yeah. Cool. IRL, it's going to be like, don't look up. This is black slime. Everyone has an opinion, says, say my name, Martha. Please, Kyle, with a New Zealand $5. Hello, Martha? How you going? So why not? So it weighs 600 kilograms. It was moving 6.6 kilometers per second. Even I can do that math. We know how heavy Dymo didn't get destroyed. And we know the kinetic energy of DART, so why not just do that simple math and see how much it will slow down? Because asteroids are more complicated than that. It is not, David Chapman, thank you. I see you. Just got timed out because you're getting a little eager. Asteroids are not like you've seen them in Hollywood. They're not all of them, but most of them are not going to be like, hey, we could land Bruce Willis on this thing and stand on it and drill into it and put a nuke on it. No. Think of this. These objects are smaller than planets, which means they don't have enough mass to spherify themselves, but they have just enough gravity to get things coming together, to bring them together. So in reality, many asteroids are quite porous and kind of fluffy. Just loose gravitational aggregation of material. Not like a solid rock. Not like a single piece of iron. No, it's like asteroids are like the dust bunnies of the universe. Just little pieces of material just accumulating over time, quite loose. Okay? Like big balls of gravel. Carolina Ghost says, you doubt the power of Bruce Willis? I do. So if you have what amounts to a loose pile of gravel, hitting it with a kinetic impactor going very, very quickly can mean some interesting mechanics afterwards. So this is in a lab, a hypervelocity projectile hitting a simulated asteroid. Now look at that. Look at how that is moving. It doesn't get destroyed as much as it gets distributed. And if you distribute material like this, the impact is too big, the asteroid is too small, you don't know its composition, etc., etc. These pieces could stay there and stay on a trajectory to hit Earth. Or you might just give Earth many, many more projectiles to deal with. That's a lot of debris. And so we study. So part of the DART mission was to test the effects of a kinetic impactor on an asteroid like this. Because what might happen could be very different than what you're simulating. We don't know the exact composition of these asteroids before we get to them. And even more baffling about asteroids, something I didn't even actually think about, was like, Kyle, why don't you just fling a nuke at it or some kinetic impactor the size of a darn house and just obliterate this thing? Well, like we said, pieces might go off in random directions, might cause even more damage than you wanted it to, and the simulation you're about to see. I didn't even think about this. You can explode an asteroid. I mean, it's technically you could do it, and we could do it. But in space, if this thing is far away, and it's far away from other stuff, and it still has gravity, guess what happens? Bam! Yeah! Yeah! Bruce, you destroyed the asteroid! Oh no! It's reforming! If you're like me, you never even thought about that. Asteroid far enough away with still enough mass to have a center of gravity. Pieces will come back together. Sammy B with another 5 finally not being ignored by me. Do the simulations also take into account Earth's magnetic field? No, that would not have the same gravitational effect in this simulation that we're doing here. Now, see what I'm talking about here? Yeah, we did it. We hit it with a huge nuke, and it's all going to. Oh no, it is still there. Okay, so this is why we have to do tests like these, because it's not as simple as hitting 2 billiard balls together. One has kinetic energy, the other has kinetic energy. Boop, boop. It is not that. We need to know the composition of these asteroids, how they act after impactment, and we need to know how much momentum we can actually translate into all of these pieces. And even furthermore, you hit an asteroid like this, all this what we call ejecta, or ejected material, has momentum of its own. And that can act to move the asteroid too, kind of like a rocket uses propellant for thrust. Everyone has an opinion with the New Zealand $5. My name isn't really Martha. Love your work, Kyle. Can we get a rocket on a smaller asteroid, then shoot that at a larger asteroid? That's basically what we did. It's just we didn't go to an asteroid first. We just built a thing with mass. Liz with the 20. Hey, Cy Kyle. My tiny humans question of the week. Titanoboa was the largest known snake in history, up to 28 feet long. No, I think it was much longer than that. It may have been the widest, but I think it was much longer than that. Because the largest reticulated python in history, I believe, got like up to 40 feet long. Yeah, Titanoboa could grow up to 42 feet long. So not 28. Still, so almost twice that. They're super cool, but they're also scary cool. Could it eat a whole whale? No, I don't think so. Whales are the largest animals to ever exist on Earth, ever. So probably not. Small whale? Really small one? Maybe. But not like a blue, not like a humpback or a sperm whale. So, we smash a $324 million probe into an asteroid because asteroids are complicated. And here is the actual sped up footage from NASA of frame by frame. Here's P. Diddy. There's Dymo. We slowly approach Dymo. Well, not slowly. It's 6 kilometers per second. And what I think is incredible is the high resolution or higher resolution photos that we got of its surface. Now look at that. That doesn't look like a solid rock, does it? Like I was saying about the dust bunnies of the universe, it kind of looks like just a jumble of rocks. And as we get closer and closer, it does look like a jumble of rocks, yeah? And then red screen of death. Impact. Fabian with the 10 says main quest objective asteroid impact completed. Asteroid capture, subquest, and asteroid mining both incompleted. Now on impact, you can do the math here. 1/2 times 600 kilograms times 6,500 meters per second squared. Now, if you do, let me just make sure here that I have the math right. Oh, that, yeah, so it's a head-on impact with an energy equivalent of 3,000 pounds or 3 tons of TNT, so 6,000 pounds of TNT, which is a lot. It's not like a nuclear weapon, but it's a lot. The interesting thing here is that this impact of this thing going that fast almost did nothing. Almost nothing. I think I did the math here. I did. So 610 kilograms is the mass of Deimos. The mass of DART, rather. 4.8 billion kilograms is the mass of Deimos. Your average housefly weighs a couple milligrams. The average human, weighs 72 kilograms. If I put these two ratios together, DART hitting the asteroid felt like a housefly hitting you at 6 kilometers per second. But you can imagine that even a fruit fly going very, very fast, if you were walking down the street and a fly hit you, you can imagine that you probably wouldn't slow down at all or stop walking, right? It's a fast housefly, yes, but so these ratios are I think a fun mass comparison. DART hitting the asteroid is like a housefly hitting you, and it wouldn't even make that sound, right? So a very, very, very small bit of mass. The amount that Deimos is proposed to slow down, or Dimorphos, I've been saying Deimos, like Phobos and Deimos, Dimorphos, is 0.4 millimeters per second. Here's a meter per second. Something like that. 3 feet in 1 second. This gigantic asteroid, in comparison, was only slowed down 0.5 millimeter per second. You can look at your ruler and see what a millimeter is. It's like, this is how much it was slowed down. Like, I almost can't even show you. So why did we choose what we chose? Why didn't we make it bigger? Why didn't we make this effect larger? Because, like I said, this thing is very far away, and the mechanics of the impact are not known. Now, here is actual footage from Earth of DART hitting the asteroid. Bam! Look at all that ejecta. I bet most of you haven't seen this yet. Look at all that ejecta. So just looking at scale here, if Dimorphos is 180 meters long, look at the puff of all that ejecta going out in all directions. Come on, man, break it down, says Sammy B with a 10. I'm attempting to, buddy. I'm attempting to. So look at all that ejecta. So it still produces quite a wallop, but it only slows down 0.5 millimeter per second. That's okay, because being so far away and having such a large orbit, even slowing down just a little bit over time will change its orbit enough such that we can observe that change. What we do is we go back, and now we're going to observe Didymos for the next couple of years. And over the next couple of years, we're going to look at the light from Didymos dim. And it dims because Dimorphos passes briefly in front of it. And when it does that, we'll be able to measure the time. The time difference between its orbit before and after will tell us how much it was deflected. Like the original orbit versus the new orbit you're seeing now, it will tell us that magnitude. And with that magnitude and everything else we're learning, we can then theoretically scale up or scale down our efforts accordingly. We have an asteroid that's bigger. We need to change it by this amount, etc., etc. And what I keep forgetting to say, but now I remembered, is that this change, I think... Yeah, so this change is going to be a change in its orbital period of 11 hours. Now, that doesn't sound like much, but remember, what if this thing was on track with Earth? It's 4 million miles away. If you hit it even just a housefly amount, 4 million miles away, even in a vanishingly small angle, well, 4 million miles on, it will totally miss Earth. So the proof of concept here is making a small but noticeable change that over cosmic distance would prove an effective redirect of an asteroid. Not destroying it, but using our science and our capability to predict the movement of the cosmic bodies to slightly alter the path of a dangerous planet killer such that it misses us entirely. And this would be the only successful prevention of an extinction level event. How cool is that? I took a break. I took a drink of water. Ultimate tiebreaker with the 10 says, I saw someone online complain that this is a waste of their taxpayer dollars. My dude, this is a survival of the human race we're talking about here. Exactly. Again, we're talking about $300 million. Look up the budget for anything else, and you will see that this is not a tremendous waste of resources like other things are. Sammy B, again with the 10. Sammy, you are vocal today. Not to sound too egotistical or whatever, but how does this science affect the next 100 years of human existence? Sammy, I hope that, just imagine the scenario. 20 years from now, we detect a large asteroid 10 million miles away, headed directly towards Earth. If it hits Earth, it will wipe out some significant portion of the population. We detect it. We can send something exactly like DART to it and hit it in such a way that even a small redirect years later will become a massive distance, and it will save people's lives. That's why this science is important. An asteroid impact is really the only natural disaster that could literally end civilization. So I think knowing more about any existential risk is a good thing. Maybe you don't, but yeah. Kush with the 5 says, hey Kyle, if there's no air resistance in space, why aren't we able to accelerate infinitely? I think you have something backwards there, Kush. You can't... Okay. So you got to get a little bit more complex with this. There is no air resistance in space, but there is still resistance in space. There are still atoms floating around the void, the most diffuse gas you can think of, like 1 atom per cubic centimeter. Very, very, almost nothing. Do you know how many atoms are in a cubic centimeter of air right now? Trillions, and trillions, and trillions, and trillions. So I'm talking about 1. There's still... So if you're going fast enough, well, you will eventually be slowed down in space. But that effect is so minuscule, that resistance is so small, that it would take longer than the diameter of the universe to slow you all the way down. Now, getting more technical, there's enough resistance in space, those lonely little atoms, that if you're going near light speed, it would irradiate you within 1 second to death. Those atoms hitting you. Now, why aren't we able to accelerate infinitely? Because I think what you meant was travel infinitely, and that's what I just explained. You can't accelerate infinitely because to accelerate means to apply some force, right? F equals ma. And to apply some force takes energy, and the math of relativity works out that to accelerate to and past the speed of light would take an infinite amount of energy, which doesn't exist, and therefore nothing with mass can travel at the speed of light, and therefore nothing can accelerate infinitely. Kyle Trevino, nice name, with a 20. People complaining about NASA wasting money annoys me. Their budget is something like half of 1% of the national budget. Yeah, perspective. But scientists have always had that problem. Politicians love to point out things like, why are you studying fruit flies and how ducks move around? It's because basic fundamental research into stuff like this, into every corner of the universe on our planet and beyond, leads to unexpected discoveries, amazing technologies. Do you know how many incredible technologies have come out of NASA with a minuscule budget? Stuff like Velcro. Velcro's pretty important. And that's from a minuscule investment. To invest in science is to invest in our future and the possibility of a better one. Write that down. I don't care if you don't have a pen, use blood. Just write it down, though. It's a fantastic quote. Who am I talking to? Who are you talking to? A guy with blood fingers on his blood on. If you don't hit it straight on, want to put a torque on the asteroid with an unpredictable spin, says Jesse Estrada with the 5. Oh, I see you, T-Car. Great point, Jesse Estrada. I did not point that out. Dimorphos was hit head-on, directly in the center of mass, specifically because, exactly what you say, smart boy, is that if you give an asteroid a spin, that's unpredictable, for one, and for two, if these things really are like dust bunnies of rocks, loosely gravitationally held, this was actually why they hit it dead on, is that they are near their critical spin, their critical rotation rate at which they would break apart. So if you hit this thing on the edge and it spins like a billiard ball, it might break it apart, and then that brings with it all the problems we were talking about before with being unpredictable, etc. T-Car with the $99 donation. Thank you, T, for supporting the facility and our fluorescent light budget. Kyle, tell your producer to chill out. Bruce Willis don't have squat on Thor. They are nothing without you. I bet Mjolnir could give a... I mean, Mjolnir is a perfect kinetic impactor. I mean, that's what it does. Sammy B with another 10. Last question. I'm very sorry. It's okay, Sammy. Just want you to chill on a whatever day of the pandemic this is. Very sorry, been asking this for a while now, but can an iron magnetic field, gouged properly, deflect even the smallest caliber of bullets? They did this on Mythbusters. They got enough magnets that they did actually deflect the path of a bullet. So yes, it is possible. And in theory, a high enough Gauss could frickin' rip a bullet apart midair. I mean, the strongest gravitational field in the universe that we know of are around neutron stars, and their gravitational fields are so magnificent and magnificently enormous. A neutron star's magnetic field is so big and so powerful it can kill you 1,000 kilometers away. It would destroy your biology 1,000 kilometers away. So, yes. Sue Wilson with the Canadian $10. Preppers would say that we need to stockpile some darts for dealing with potential future cosmic threats. Are they doing this? No. So I don't know the actual economics of doing something like that, Sue. I imagine that because, well, it depends, right? If a killer asteroid is 10 years out, I think you can get something built, purpose-built for that specific asteroid within that time and send it out, right? So I don't know whether or not it's quote-unquote worth the cost-benefit to either wait for detection or do it preemptively. I don't know. That's an open question. Depends, I think. Freddy Ontenil Espinosa with the 5. Hey, Kyle, loved the show. A few days ago, I was watching your Homer Simpson video and reminded me of a case in Yanango, Peru, where that happened. Freddy, I have good news. Well, it's not good news, but it's interesting news. If you watch our Half-Life histories, go back into the main channel, go to our Half-Life histories playlist, and look up the Goyonia incident video. I mentioned what happened in Yanango, Peru. And I didn't show everything that happened there because it was pretty rough. But if you want to learn more about that, go ahead and please check it out. Selena Burke, seen you in the chat asking interesting questions. You ever wonder if exoplanets and other galaxies are physical manifestations of alternate histories being played out, like the behaviors observed by light taking multiple paths described by Feynman? That's a lot, Selena. I don't think exoplanets and other galaxies are alternate realities or different realities. No, because we don't have any observations that tell us that they're anything more than what they look like, which are just planets and galaxies. But the many paths that you're describing that Feynman went through, like, I forget, least time, path of least time, is interesting. It's an idea that says that a photon of light literally does, in the case of quantum mechanics, literally does take every single possible path, even backwards through time, between point A and point B. But when we observe it, all of that collapses down into the path of least time. And that gets you into some pretty weird headspace. I totally agree. Yeah, says Mooncat, thank you. Carolina Ghost with 5. Hey, Kyle, you think NASA will ever send a satellite into a black hole and just see what happens? No. Probably not. Because you all know that the event horizon of a black hole is the point at which you can't escape. But if you think about it a little bit, just think about the actual word, event horizon, it blows your mind even more. Because it literally means event horizon. Information, action, time. That is the horizon. The point at which no event could be observed afterwards. No matter what you did, no matter what you... So I'm saying literally, you send a probe into a black hole, crosses the event horizon, and then tries to shoot a light speed beam of information out, and it can't. The information at the speed of light isn't traveling fast enough. And so the event horizon represents a point at which no events can be observed. Crazy, right? So it would be a waste of a probe, is what I'm getting at. Sending one in an orbit around them, that might be more interesting. Matthew Smith, first time catching a live stream. Keep being awesome. Matthew, keep being complimentary of me, and we'll get along great. Theory time. Mason Anders with a 10. We somehow detect a relatively small black hole on direct collision course with Earth. Could we yeet Mars at it to save Earth? Could you hit a black hole? I don't know, Mason. Since black holes do orbit each other, I mean, black holes, gravitationally speaking, aren't... This man looks like a gigachad. Says ambient with a check mark. Look, if this is your first time here, Ambient, that's because we do science communication, education a little bit differently here. I'm not your average science enjoyer, okay? We're all chads here. Okay. Wait till you see my hair. Jeez. Black holes aren't crazy gravitationally. By which I mean, if you replaced the sun with an equal mass black hole, it would be smaller, but an equal mass black hole, all the planets would orbit in the exact same way. There's nothing special about its gravity. It just has a lot of mass in a small space. The most mass in a small space, in fact. So, to your point, if a black hole was headed towards Earth, much like an asteroid, I bet you could gravitationally interact with it, which is the space tugboat idea of deflecting an asteroid. So you could put something in orbit around this small black hole that over time would move it enough that it would miss Earth. That's what I guess you'd have to do, because I don't know. I don't know off the top of my head if you hit a black hole with something, is momentum imparted in the same way? My gut says yes, but black holes aren't, they're not like a big black sphere. They're more like a omnidirectional hole. So I don't know. That's a higher tier physics question that I don't know. Could you impart momentum in such a way to deflect it? I don't know. If nothing can escape a black hole, why does Hawking radiation escape? Does radiation travel faster than light? No. So Hawking radiation, we're getting way off topic here. Way off topic. Are artificial black holes a possibility? Sure. Just need enough mass and enough space. We don't have technology to do it right now. But what was I saying? Oh, so what Stephen Hawking postulated was that black holes can lose mass as virtual particles and their partners pop into and out of existence. So what if my face here was the event horizon? If virtual particles, and we know that this happens, are popping into and out of existence everywhere, what if a particle pair, one was on one side of the event horizon and went, but one wasn't, and could escape? Now, these are still a pair, but one of them gets destroyed. The other one escapes. And so to maintain the conservation of energy and momentum in that scenario, the black hole has to lose mass, because it gained mass from this other particle. Gained mass from this virtual particle. So it has to lose mass. And so Hawking radiation is that process over time, and it takes trillions and trillions and trillions of years. Are all black holes the same size? No. Are virtual particles still theory or part of cosmology? Says Cam Plays. I don't know. I mean, I know they're things, but I don't... It's a hard question. I think they're established. Virtual particle is a theoretical transient particle that exhibits some of the same characteristics of an ordinary particle, while having existence limited by the uncertainty principle. There are many observable physical phenomena that arise in interactions involving virtual particles. Yeah, so it seems like it's part of cosmology to me. Please define virtual particles, says T-Car. T. See how far your money goes? Whew. Woo. So chat, before we're done today, next 10 minutes or so, before half an hour from now we hop over into sciencing Titanfall 2, which I'm very excited to do because that game has one of the best first-person shooter campaigns I've ever played, and it's super duper sciencey. The people at Respawn, the same people who make Apex, that's where Apex Legends came from, by the way. It's after Titanfall 2. They have great storytelling and world building. There's a whole level about time travel in which you time travel back and forth between realities while shooting guns. It's sick. We'll do that in a half an hour. But before we do that, I just want to catch you up on everything. I've been gone for 5.5 weeks. We've been doing a lot at the facility, and I want to catch you up on everything. Jared with the $9.99. Update chat. I tried my Australian accent out with an Australian friend of mine, and she said that it was pretty bloody good. So, We've done it. We did it. If the center of black hole has infinite gravity and gravitational strength correlates with time, wouldn't that mean that time can't move forward in the center? If so, how could the center ever come to be? Says Jared. I know, right? At the singularity point of a black hole, physics as we know it breaks down. And you say something interesting with time there. I will, because an event horizon is the end of all events and information. I want to blow your mind with something, Jared. Okay? Let me just blow your mind with something, Jared. If you fell into a black hole, we wouldn't see you fall into a black hole. Time for you would effectively stop the moment you crossed the event horizon. And the last thing that we would see of you is the last thing you did at the event horizon slowly fade into nothing. We wouldn't see you fall. We wouldn't see you spaghettify. We would just see a lingering, ghostly image of the last thing the universe knows you ever did. Zach Connolly with the $4.99. Question. If lightning hits an asteroid, does that asteroid become magnetic? Zach, please leave. Zachary Porritt with the 20 says, could particles that seem to teleport just be passing through a fourth spatial dimension? Maybe. But we don't have evidence for that. That's actually one of the ideas for why gravity is so much weaker than the other fundamental forces, is that gravity is more located in a different dimension and is only leaking into our dimension. But we don't have time to get into that's. We don't have time to get into all that, trust me. Jay Arrows with the $9.99. Black holes make the best spaghetti in the whole universe. I don't know if you'd want to eat people's spaghetti. So, since I last saw you, I think we did Dungeons and Dragons in space. We talked about, I let an artificial intelligence write an entire science video, and that turned out very funny. We did another Half-Life history about history's worst software error. We also talked about the Eagles. I show you that we went inside the new safe confinement in Chernobyl. I saw the sarcophagus firsthand. I'm one of the very few humans alive that have ever done that. It's like walking on the moon. So watch that video if you haven't yet. It's one of our finest works. I also went to a climbing gym to show you that rock climbing like a video game character will destroy your life. Now, I don't have time to go through 6 videos worth of comments and award you nerds and stuff, so I'll just give you a brief update on what we're doing here before we go over to the gaming channel and game for a while today. No, I don't want to talk about brain theory. It's complicated. Marlon May with a 5. Hey, so do you think the next experiment will land something like an ion thruster on a rubble pile to apply a small constant redirection thrust? Marlon, that's... So DART had an ion thruster on it. I think landing, affixing yourself, and then thrusting is probably a much harder mission. So I don't know if that's the next mission. I imagine the kinetic impactor is the easiest thing to do. So I don't know. Coming up at the facility. Well, of course, we're going to play Titanfall 2 and science the crap out of it in just a couple of minutes. Kyle, what brand of socks do you wear? Says Frogman. I haven't worn socks in like 3 years. Unless I have to. Just, I haven't worn hard pants. Haven't worn socks. I'm mostly just around the facility by myself in my Kevins. I don't need to put on shoes or socks. We got heated floors. You ever walk on a nice heated floor? Whew, change your life. Coming up. Pleased to tell you that we have an update to Roko's Basilisk coming up on the channel. That was our channel's first viral video. We have an update on it. A philosophical, moral update on it. And then next, maybe the video I'm most excited about from Chernobyl is the dogs of Chernobyl. Like going inside and seeing the sarcophagus, I believe that we have the best footage, maybe in the world, of what is possibly the rarest and most unique dog breed on the planet. You'll see dogs. You'll see puppies. You'll see Chernobyl in a way you haven't seen it before. And it's going to be a fundraiser so that we can raise as much money as we can to help out these dogs directly. It's going to be great. Some of you, yeah, so multiple people saying two-headed dogs. This is going to be the point of the video. These dogs are these dogs are gorgeous. These dogs are gorgeous, healthy, intelligent. They're incredible. And we'll go through all of that. They're not rabid. No. They're wild. But they all look like house pets. Because they came from house pets. But we will go through all that history in just a couple of weeks. Dogs of Chernobyl sounds like a rock song title. I know, right? Don't do that. Chat, in just a couple of minutes, we go from... Oh, you know what? I'll do... Chat, follow me for a second. Come on. Chat. In just a couple of minutes, we will move from where we just were doing stuff to the Facility Gaming Command Center, where we will, using multiple screens, multiple gaming chairs, we'll be making our way through Titanfall 2. We're not going to do the whole game today. That'd take like 8 to 10 hours. I ain't got that kind of time. But we'll play for probably 2.5, 3 hours, and we will science all of the very cool science in that game. I hope you join. You'll be, once I end the stream, you'll be automatically redirected, so you don't even have to go anywhere if you don't want to. I hope to see you there. Chat, we spent almost 45 minutes talking about the DART mission. If you have any additional questions, comments, corrections, please put them in the comments below. Or, of course, you can go to patreon.com/KyleHill, get your access badge to the facility so you can join our members-only Discord. One of the nicest, most nerdiest Discords people tell me they've ever been in, and you can talk to me directly. Some of you were DMing me about this before I even started streaming. You can reach me anytime, any day. But, I mean, I won't respond at any time. You know what I mean. But you can come join us here in the facility, and we can get this nerdy every day. Thank you to Jabo and Heather for moderating. Thank you to all the newbies who made this their very first stream. I'm happy to be back. You can tell I'm still lingering with something in my voice and my brain, but we're back. I hope you enjoyed the last hour or so. What's the length of your hair now? It's been so long, says Jack. If you want to see my hair, you're going to have to tune in into the next stream, baby. But it's like here. It's only been 5 weeks. Okay, well, soon. Glad that you're back, says Demon Corcoon. Demon Corcoon, happy to have you here. No matter where it is, I forgot. What's the thing I say at the end? Hey, no matter where I see you next, whether it's on the next main channel video, whether it's on the next office hours, whether it's on the Discord, in the comments, whether it's in 30 minutes as we game and science at the same time, the only gaming science streamer in the world. No matter where I see you next, I hope until that time you have a wonderful rest of your day or the number of hours that you're conscious. And until then, be nice to each other, because this is all we got. See you soon.